Hey guys, thank you for everything. Nice to have you here. I'm Igor, and I want to talk about unit testing and actual unit testing on Android. A little bit about me. So I've been developing mobile apps for some years now, and working at Mockito, cool startup in Italy. Why should we bother at all with unit testing? Why should we do that? And I guess first and foremost is that manual testing doesn't scale. You develop a lot of features, and then if you try to test them manually repeatedly, that just doesn't work. Your releases will take a lot of time, and you won't be confident to release at all, and you won't be comfortable to change your code, because every time you add something new, then you should go through the app and test everything and make sure it works. And actually my personal favorite, I think test-driven development, actually developing with testability in mind, really helps you with your code and with your architecture. Because in order to be able to develop tests, you have to have good quality code. It's just that simple. The most important part is to follow guidelines and software development practices. So let's try to define a unit test actually. When I talk about unit tests, it's a test which tests one single component. So it shouldn't be dependent on configuration or external collaborators. When I talk unit tests, it's really testing one single piece, one single module of your code. So we replace real dependencies with test doubles to be able to simulate the behavior of the class. So why should you focus on unit tests, not UI tests, not integration tests? Unit tests are really fast to execute. And I will show you a bit later. You don't have to deploy unit tests to your device or to the emulator. You can run them directly on your machine. Easier to maintain and really fast to develop compared again to UI tests or integration tests. So what do you need to develop unit tests on Android? And it's actually true for all the platforms. If you go to iOS, or I don't know, if you try to do web development, it's basically the same core principles you need to apply. First, most important is you should try to separate your business logic from your platform code, from your views, and actually from all the code which is related to, say, Android system. Your business logic shouldn't be within activities or fragments or services, and I'm going to talk a bit about this later. Solid, single responsibility, dependency injection. I bet you all know what this means. But and you might think that you apply this, good practices while you develop. But if you try to write a unit test for what you develop, you usually uncover different problems within your design. So it's really important to try to follow these principles. And of course the tools like JUnit, Mockito, and TroubleElectric really enable you to write unit tests. And I'm going to talk about Mockito a bit later. So let's start from decoupling business logic and your platform code. Most likely when you see the legacy code, or not legacy code, but any code on Android, you just see big activities and big fragments which have different kind of logic. It's not only showing the data in the views, not only binding the data to the views, but also people load data, they process data within activities, within fragments, within services. And then this breaks single responsibility actually. And then you're not able to develop unit tests because you don't have small units and you cannot test big God classes. And this actually maybe not your fault, Because when you go to documentation or like to any tutorial on Android development, to Google developers' website, you see these samples which are built around, big activities, big fragments, big services. And then you try to build on top of that. And you end up with this architecture where everything is really coupled, and it's really hard to separate it. And you might, want to refactor it at some point. But if you follow the same principles, then you fail usually. And since activities and fragments are actually, the most problematic parts of code, which are really big, then let's talk how we can handle that. Model view presenter. I bet you at least heard about it. It's become really popular, but not in the context of testing. So you see this example, right? This is activity. It's really simplified, but it gives you an idea like what's happening most of the times. So you have this onCreate methods, and you have API service, and you get the data, and then when you get the data, you make the decision like what to do with this data. Should I display it, or should I show an error if the data is empty, or like my network request failed? So it's really simple, but that reflects what you have in the most of code bases. And we want to separate that. We want to decouple your view logic from presentation logic. And when I say view logic, it's not like Android views. The view in the context of MVP, it's an entity which gets data and binds them to Android views. It binds the data to user interface. And that should be the single responsibility of view in MVP. Okay, so here you see I define interface, which has two methods. And my activity actually implements this interface. And then inside these methods, the activity can decide what to do with them, like show them in the list, or display a dialog with an error, or whatever you want. And then actually, the most important part, what you should test, is actually your business logic. Most errors, most bugs come from your business logic. So, and you do this by testing the presenter. So presenter is an entity, it's a class which decides what to do with data, how to govern the view to display the data. Like presenter knows, okay, what's the state of my data, what's the state of my application, and then it will tell the view what to show. And that's where you keep your logic, your business logic, your use cases. Because most of the apps we develop actually deal with data. They get the data from somewhere, from web service or from API, and then they show the data. And you see it's nicely decoupled. The decisions we make, what to do with the view, is contained within the presenter. And now you can see the tests which we can develop for your presenter. Again, it's really simple, but the first test, we use Mockito to mock the dependencies. And in the first test, we say, okay, when API load data, then we return some data. And then we make a verification that presenter calls show data on the view. And in the second example, we say, okay, when some calls API load data, then we return some empty data, some error. And then we verify that presenter calls a view show error. Again, it's really, really simple, but in the reality, I bet you would have, much more logic in presenter, You would get data from services, from database, from third-party SDKs, and you have, a lot of this if-else branches when you show different data. And by decoupling this, you can really, really easily test it. So, next. What's really important, actually, to develop unit tests is to be in charge of your dependencies. You might have heard, about dependency injection, Dagger, RoboJuice. all these frameworks. But you should, when you develop a class, when you develop a component, you should really know what are the dependencies of this class. Otherwise, if you don't know, like if they're hidden somewhere, then you cannot replace them in your tests. So this is really important. One word of advice. Like first, if you think of dependency injection and if you think of tests, don't try to use these frameworks right away. I've seen people try to do that, and they usually get frustrated because you need to configure them. You need to take your time. The learning curve is really big. Just try not to use them right away. What you can do instead, you should try to manage dependencies yourself. So I bet you have that, or you've seen that. So you have these singletons, right? And within your classes, you just go, okay, singleton get instance, and then do something. And then when you try to unit test this class, it's not impossible to replace the dependency, but it's really hard. Try not to do that. Actually, your class, which has a dependency, it shouldn't be aware whether this dependency is a singleton or not. It should work just with interface, which it cares about, right? If this class gets data from backend API, then it shouldn't know that the backend API is a singleton. So what you can do actually is to use constructor injection. It might seem obvious, but not a lot of people do that. So you see, this is much better. Now our class doesn't know if backend API or DB helper is singleton or not. It just doesn't care how this class is constructed. It just works with interface. Again, about this dependency injection frameworks, you can do that with Dagger or RoboJuice. But it feels like when you do that, you just you use this framework as a manager for your singletons. You actually don't improve your design of the class, but you just hide this behind the framework. Might seem like a good idea, but when you have a lot of this and you try then to configure this DI framework in your tests, then you have trouble. So instead, actually, because people say, okay, then I have to change interface on my class to accept these dependencies in constructor, and I do this only for tests. And this seems like an overhead, right? But you can actually use that if you follow this pattern that your tests live within the same package as your production classes. Then you can use package private constructor. In tests, then you can provide dependencies for your class using package private constructor. But in your production code, then you use this empty constructor, which still constructs the singletons, right? But your client code, where you use this friends interactor, it doesn't have to do more job to get the dependencies. Okay, so the tools, tools are really important because without using Mockito, you would struggle to write unit tests. You would be wondering, okay, how do I replace my dependencies? How do I deal with them in the tests? And I'm going to show Mockito a bit later. JUnit, I bet everyone knows that. It's the most important part and the core framework. And there are other frameworks for Java, but I don't think you should use them. There is just no need for that. And there are a lot of examples for JUnit, how to write tests. Actually JUnit 4. Roboelectric. Roboelectric is something which we also use, and it's also used for unit tests on Android, but primarily it's used to deal with Android dependencies. like whenever you have activity or fragment or I don't know service, and you want to test it, you want to construct an activities or fragments in your tests, you would use Robolectric. But again, we try in Memorado, we try not to use Robolectric. Since first, Robolectric tests run much slower than plain JUnit tests. And again, we try to get rid of Android dependencies in our business logic. This means we use Robolectric just as a last resort. Yeah, assert.j is something not so important, but it's asserting fluent assertions library. Makes your life easier. Okay, so now let's talk a bit about Mockito. So for unit tests, again, you need to be able to replace your real dependencies with test doubles. And test doubles can be stubs, mocks, you know. Mockito can help you with mocks. So whenever you have a dependency in your test which you need to replace, you would use Mockito in order to be able to simulate the behavior of your dependency. You can just say, okay, when someone calls my dependency, then return this, and in another test you could, you know, replace what it returns. And you can also do verifications. And verifications, as you can see in this example, so we have this class notifier, right? And it has a dependency on vibrator, and it's like from Android framework. And you will say, okay, how do I possibly test this stuff in my unit tests? How do I verify that actually my application vibrates for notification? Yeah, well, you can use Mockito. Just like that. So you say that you mock vibrator, and when you create your notifier class, you just supply an instance of vibrator to your notifier. And then you say, when I call notify on notifier, then it interacts with my vibrator class, with this argument. And that's like really simple example, but in reality, you can do the same for, you know, notification manager. Say you receive push notification, how do you test that your code, your business logic, calls notification manager from Android framework? Well, you can just mock the dependency, and you can verify interaction using Mockito. And it's really powerful. The only limitation, I guess, is that it cannot mock private final classes, which means if you try, you know, to mock some parts of Facebook SDK, or, you know, I don't know, then you need something else. You can use PowerMock, but for most use cases, Mockito is fine for you. And again, like, spend some time to, if you don't know yet, try to find how it can fit in your testing workload. Yeah. So a little bit about actually what happens after we wrote the tests. So we use GitHub and we use Jenkins for continuous integration. And what we want to achieve is that we don't merge features into master unless we know it's running and it's building the test run. Because we had a lot of troubles before with that. So we were accepting pull requests, which then fail and break the master, and you try to fix it. So GitHub has this nice feature called protected branches, and you can say, okay, don't merge anything to my master unless the checks pass, unless the tests run. So you see, you submit a pull request, and then you cannot merge unless the tests run. And then, yeah, then when they run, you see this, everything is fine. Okay, my test run, builds, go ahead and merge it. About speed of unit tests. Okay, actually you can run them in Android Studio. As I told before, you don't have to deploy them to device. This means they run really fast on your machine. And as you can see, we have how many, like 770 tests, and they run in, say, 50 seconds, right? So, yeah, you can scale it much more. You can have much more unit tests. and they won't interfere with your workflow. And if you try to do the same, say, with end-to-end tests, with like heavy integration tests, with instrumentation tests, then it will take you ages to build the single flavor. And if you have more flavors, if you run end-to-end tests, multiple flavors, and it takes you ages to do that. With unit tests, it's much more faster. Okay. Well, some closing remarks. In the end, it's all about your architecture. If you have a good architecture, if you think like, okay, my classes are well structured, I manage my dependencies fine, try writing unit tests for your classes. And you will see that all the problems which you have will come, to the surface. And actually, I think unit testing plays really, really nice with TDD. Like, you shouldn't try test-driven development right away, but at some point, you might come to that point. You start with your tests, and then the core principle of TDD is that you don't write code unless it's enough to make your test pass. So you don't end up over-engineering your code, over-engineering your application. You just write just enough code to make it work. And then, you refactor it. And then when you make changes, it's really, really easier for you to make them. You're not afraid. We build complex applications nowadays, right? It's not small applications. And when you develop a new feature, usually, it's hidden within like login page, sign up page, and everything. And sometimes it happens that you just develop code, which is really, really hard to reach in your application. And then if you try to test everything manually, it takes you ages. That's the argument, like, a lot of people say, okay, I don't have time to write unit tests. We change a lot, we develop a lot of code, and I don't have just time, it changes so fast. But I find it really, really useful for, even on the development stage. I write a small piece of code, and I can instantly verify that it works. And I can check that my changes don't break my other code. And also we are a startup, right? This argument you hear from people, okay, I don't have time to write tests because we are a startup, we develop a lot of features. Well, it's not true. This is a GitHub repository, and I tried to gather some best practices, or good practices, for MVP, for architecture, for tests, like test resources. And I encourage you to visit that, and you will find books and tutorials about testing, Robolectric, Mockito, MVP, because there are not so many resources actually about testing on Android. I guess that's it. Join Memorandum. We make people smarter, and we're hiring Android developers. So if you feel like you're up to the challenge, go talk to me. Even if you don't want to join Memorandum, again, talk to me. I'll be glad. I guess we have time for Q&A.
Yes, we actually have lots of time for Q&A, and like all the other speakers, you get a speaker gift, which is an awesome cup, because every developer needs coffee, right? I hope you drink coffee too.
Oh, a little bit.
Okay, so.
Thank you.
He's a real developer. He drinks coffee and tests code. So. Who of you here has tests in there?
Actually, I'm sorry. I wanted to ask a question first, but I forgot. Like, how many people of you tried to develop unit tests on Android?
Try to develop this.
And how many people find it difficult to do? At least some of you. That's good. Yeah.
Okay, but who tried 3 years ago? Okay, that's a lot less. Did you like it back then? Okay, that's none of the people that... Oh, do you have questions? Sorry. Keep on running.
Maybe not a big question, but I noticed on your first, one of the first screens with the tests, you did some verifications from Mockito, and I'm just curious about the syntax, because it's far as I know, the Mockito syntax is like verify, and then you have object in parentheses, and after that you call the method. And you did like all together in method. This changed in some version?
No, I mean, it might be a mistake there, yeah, but the syntax is like you mock your dependency, you mock your class, and then, yeah, you say that you verify given the instance, and then which method gets called. Yeah, that's okay.
Hi. One question about studying, about applying TDD. What is your favorite approach when you start to write a new feature, for example? You go outside in or inside out, if you know what I'm talking about?
You mean like user interface or?
It's like a more general approach. You start from the requirement, you go deep to write all the little components that will eventually make your feature, or you start from the little unit and go out to the feature?
Well, yeah, the good part about using this MVP and this good practices is that your code is actually opinionated, and you can expect some structure from, say, you develop user interface, you develop a new screen, and I know like exactly what I need. I need a model, I need a view, I need a presenter. So usually if it's a screen or it's like, yeah, a new screen, I would start with presenter and I would try to do TDD for it. So I would say, okay, what do I need to see on the screen? And then I make my presenter, do exactly that, not more. And then I, go by each layer. Yeah, I mean, you can see another frameworks also, like in web development, people start with end-to-end tests, say Angular, or it's like testing culture is big in Rails. They start with end-to-end tests, and they write a spec for a page, and then they do integration testing, then they do unit testing. On Android, yeah, you can try to start with integration tests, and then try to satisfy them, but again, they are slow, and it takes configuration. So I will start with unit testing and MVP, yeah.
You said Robolectric only as a last resort. If you need one more weapon against that, there's a nice plugin, it's called the Unmock plugin, which just uses some stuff of Robolectric, but not all the shadows. But you get JSON array back, you get URI back, and you don't have to exclude that.
Yeah, I mean, I will check it out, but again, like, it's when you talk to people and you say, please abstract away from Android framework and try not to couple with it. They say, okay, you don't want to use what's developed by cool developers for you, and you want to reinvent from scratch. Yeah, it's not true. Just we try to separate our business logic to make it completely independent from Android framework, from the views and from all of that. Of course, as you said, there are cases like URIs, resources. You have to do that, but again, you can try to do this with Mockito. You don't always have to use Robolectric. Yeah, I mean,
Can you please repeat the question for the camera?
Yeah, whether I would test activity, which I showed on the first slide. I would say no. I could write instrumentation tests for it. But again, I would, like, with the structure I showed, it's really hard. You can do this with Espresso, but then again, you need to use dependency injection frameworks because you just cannot easily inject stuff into activity. Then, yeah. So usually, no, I don't test activities that much until I absolutely have to. So I would try to decouple everything from there and to write a unit test. But again, like, maybe you should try have some end-to-end tests, some instrumentation tests, on a big level, on a big picture, but not a lot of them. Just the core, the foundation of your test should be unit tests. Any more questions?
We still have lots of time. Ask your unit testing questions.
So, when I have normal unit tests and unit tests using Robolectric, is there an easy way to just say, okay, I just want to run the ones that have the normal JUnit runner?
You mean, is there any way to convert robolectric tests to JUnit tests?
No, not to convert, just that you say don't run all tests, only run the runs with the normal JUnit runner and test suites.
Well,
configuring test suites.
You mean separate? Yeah, I mean, I guess you can do that maybe with separate test modules. I haven't tried that, but yeah, I guess you can do that. There are samples from Google where they sort of have a separate Gradle configuration for running tests. Your code for your functional tests is in a separate module, and you can run it separate, of course. I guess, yeah, you can do that.